So I think we'll start with the session. Good evening, everyone. Once again, welcome to the uh, FDP session organized by TocH Institute of Science and Technology, Kochi, Kerala. Our FDP program is entitled Next Gen Intelligence HPC Applied AI and Data Science. And today is the fourth day of the FDP program. I have already briefed the sessions which happened on the past 3 days. And for today, we have sessions planned, and first session is object detection using single shot algorithms, which will be handled by Mr. Lomin Joy. I hand over to the coordinator to welcome our resource person for today.
A warm welcome to all. On behalf of TocH Institute of Science and Technology, it's my pleasure to introduce our esteemed resource person, Mr. Lomin Joy, Senior Project Engineer, IIT Palakkad, to this session. Mr. Lomin Joy is a seasoned technology leader, AI innovator, and senior embedded system engineer with over 18 years of experience in artificial intelligence, IoT, machine learning, wireless sensor networks, and real-time embedded solutions. As a co-founder of TocH AI Automations and a senior project engineer at IIT Palakkad, he had delivered high-impact solutions that enhance system efficiency, reduce deployment time, and strengthen predictive intelligence across critical applications. He has led the development of AI-driven automation platforms, architected intelligent service frameworks, and deployed advanced sensor networks for environmental monitoring and landslide predictions. Mr. Lomin is recognized for his leadership and technical insights, having guided 10 plus cross-functional teams and delivered 20 plus workshops on ML, IoT, and embedded systems, and mentored numerous students and engineers in advanced research. His professional background spans academia, industry, and collaborative research, including key contributions to the ISRO Response project and wireless sensor network development. With a strong expertise in Python, C, C++, Java, microcontrollers, cloud platforms, and edge computing, Mr. Lomin combines practical engineering skills with strategic innovation supported by international publications and signature projects in intelligent systems. Welcome, sir, to this session.
Thank you for the introduction. Let me ask the most cliche question in the FTP, online FTP. Can you hear me okay?
Yes, sir, you are audible.
Okay, fine. Let me share my slide.
Yeah, you can.
I think the slide is visible.
Slide is visible, sir, but that Google Meet screen is also side by side visible, I think.
Okay, I will.
Yeah.
Okay, now
yeah,
fine.
it's now fine. Sir, can you kindly switch on the video for a minute so that we can record the thing also? Yeah, okay. Thank you, sir. Okay, sir, you can start with the session.
Sir, you are on mute.
Hello. Am I audible?
Yes, sir, it's audible.
Okay, fine. Okay. Again, I think the audio is muted in the middle of the thing. So, a big thank you to the organizer. So, the first request from my side is you take the laptop with you. Then, at the end of the session, I will plan to some practical sessions with the real time modeling. So, it's okay if you are with the laptop. So we just started our today's session. Okay. First, what are we doing today? Today we are going to dive into something that's really practical: object detection using single shot algorithms. And now I know that sounds some technical, but don't worry. By the end of the session, you will not only understand how it works, but you will actually build one yourself, one model. Okay. And this step is everywhere now, like self-driving cars, security cameras, and those Amazon Go stores, and where you just walk in and walk out. You know the Amazon Go stores from that videos, YouTube videos. You're familiar with that. And even in medical imaging, it's one of those skills that super in demand now. And I will try keep this as interactive as possible. If you have questions, just drop them in chat, and I will address them as we go. Okay. Then we go to the next session. So let me start with a really simple question. When you show a picture to a computer, what can it tell you? There is two options. One is image classification. The computer says this is car. Just one word, one label. That's it. And it's like asking your friend what is in the photo, and they say a car. That's simple answer. And option two is object detection. Now here is where it gets interesting. Object detection says there is a car here, and there is a person here, and there is a street light over here. So it is not just what is in the picture, it's what and where. That is a big difference. And for each detection, we get three things: a bounding box, that rectangle around the object, a class label, what the object is, and a confidence score, like 96% it's a car. And this is the foundation for things like self-driving cars and surveillance systems. They need to know where things are, not just what they are. I think it makes sense so far. We can move to the next slide. And in this slide, we are discussing why real-time detection matters. Okay, here is the thing. Detecting object is great, but if it takes 5 seconds to do it, that's a problem. Let me give you some real example. If you imagine the autonomous driving. A car going 60 km per hour covers about 70 meters every second. If the detector takes half a second to spot a pedestrian, that car might not stop in time. That speed literally saves lives here. So I think you got the point. I will move to the medical imaging field. Imaging a surgeon in the middle of an operation, waiting for an AI to analyze an image. A few seconds of delay could be critical. We need instant result. And also in manufacturing quality analysis, factory lines move fast. If a defective bottle passes through and AI catches it 2 seconds later, it's already packed and shipped. It's too late. And retail, we already discussed the Amazon Go, those stores where you just pick stuff up and they walk out. The system tracks every item in real time. If it's slow, your bill is wrong. And in the case of surveillance, airport, malls, secure buildings, they need to spot threats immediately. A 3-second delay in detecting an abandoned bag, that is not acceptable. So the bottom line is, we need detectors that are both fast and accurate. That is exactly what single shot detectors give us. One pass and done. Okay. Next, let's talk about the two main approaches to object detection. This is important to understand. Two-stage detectors. Think of it like a two-step recipe. In step one, the model scans the whole image and says, maybe there is something here, maybe something there, and it proposes a bunch of regions. And in step two, then it looks of each region closely and says, okay, this one is a car, this one is a person. The result is very accurate, high precision, but slow. We are taking 5 to 10 frames per second. That is not fast for real-time video. And comes to single shot detectors, single shot is different. It is a one-step look and do approach. The image goes in, and in one pass, the model predicts all the boxes and all the labels. No separate proposal step. The result is 30 to 160 frames per second. That is real time. That's what we need. And so here is the bottom line. Two-stage equal to precise but slow, great for offline analysis. And single shot, fast and accurate, perfect for live video, edge devices, and real world stuff. That's why we are focusing on YOLO today. It is a workforce for real-time object detection nowadays. Then YOLO. YOLO means, let's talk about YOLO. The name says it all. You only look once. That is YOLO. One look, one pass, all detection done. And let me break it down into three simple steps. In step one, you can see, split the image into a grid. Imagine chopping the picture into a 5 to 5 grid, like a chessboard, and each cell gets a few anchor boxes. These are like templates.
Sir, sir,
So,
sorry for the interruption, sir. Sir, can you please hide the sharing bar on the screen? Like we
oh,
can
okay.
read the content.
Okay, sorry.
Thank you, sir.
Now it's fine.
Yes, sir, it's fine now.
Okay. So let me rewind this thing. In step one, we already discussed the split the image into grid, and each cell gets a few anchor boxes. These are like templates. The templates means the tall ones for peoples, wide ones for cars, and small ones for signs. And in step two, predict everything at once. For every anchor box, the network predicts where the object center is, how wide and tall the box should be, and how confident it is that there is an object and what class the object belongs to. And all of this happen in one forward path, no extra step. And in step three, get the result fast because there is no proposed region and fast and classify the later pipeline things. YOLO is lightning fast. We are taking 30 to 160 FPS frame per second depending on the model size. So why does this matter? There are three things: speed, accuracy, and simplicity. Speed means one pass equal to instant result. And accuracy means anchor boxes handle different shapes and size. And simplicity, fewer stages, easier to train and deploy. That's why YOLO is the go-to choice for autonomous cars, security cameras, retail analytics. That is, we name it, you only look at once. Okay. Then when it comes to handling multiple objects. So what happens when there are lot of objects in the image? And what about all those overlapping boxes? You can see the overlapping boxes. And remember the previous slide. Each cell is like a tiny dictative, and each dictative can send out multiple anchor boxes, different size and shapes. You can see. So if a person and a car are standing right next to each other, one cell can still detect both. One anchor catches the person, another catches the car. This is how YOLO handled crowded scene. And the problem is too many boxes. That is the issue because each cell fires multiple anchors. We often get several boxes for the same object, like 5 boxes around one car. And the solution is non-maximum suppression, NMS. This is the cleanup step. Here is how it's work. I will explain. Sort all boxes by confidence in first step, the highest first, and keep the top box. And throw away any other box that overlap too much with it. And repeat until each object had exactly one clean box. And this happen in millisecond, not get too much time. So the anchor boxes let YOLO dictate many things, and NMS clean up the duplicate. Together, they keep YOLO fast and accurate. Okay. Next, the architecture of YOLO. YOLO have so many versions, and latest versions are YOLO 11 and 12. That's why I took the YOLO 11 and 3. It's a human body, three main parts, and they all work together. First part is its backbone, the brain. And this is where the image gets processed layer by layer. The network extract the features from the image, edges, texture, shapes, parts, and whole object. And it produces the feature map at different scales, P3, P4, and P5. And these are the pyramid levels. Pyramid levels means P1, P2, P3, P4, P5 are there. P1 means 2 into downsample. It's used for high resolution. P2 is again 4 into downsample, again high resolution. P3 is 8 into downsample. So YOLO starts here. And this is important because objects can big or small, and we need to detect all of them. Then second part is neck. Neck means a spine. The neck takes those features map and fuses them together. It uses something called FPN, Feature Pyramid Network, which send high-level context down to finer maps, and PAN, Path Aggregation Network, which send detailed information backup. And by the time features leave the neck, every scene knows about the old scene. So the third part, head. Head means the hands. Finally, the detection heads make the prediction. There are 3 of them, one of each scale. Each head outputs bounding box coordinate, that object confidence, and class properties. And all 3 heads fire at once. One forward pass, and that is a magic. So to summarize, backbone used for feature extraction, neck feature used for feature fusion, and head for prediction. And together they make YOLO a real-time multi-scale detector that can run even on modest hardware. This is the basic architecture of YOLO. And why we are using the model YOLO, there are different sizes. Different sizes means think of like cars, a small car, a sedan, SUV, a truck, and each good is for different situation. And I will give that quick background. First one, nano, N. You can see the N. N means nano, super small, 2.6 MB, 160 plus FPS, great for phones, drone, and edge device, but lower accuracy. Then small, S, good balance, 80 to 120 FPS, work well for real-time surveillance and small servers. Then medium. Medium is the main workhorse, 50 to 80 FPS, solid accuracy, good for autonomous vehicle prototypes and quality control. Then large, L, higher accuracy, 30 to 50 FPS for critical security and research labs. Then extra large, X, maximum accuracy, 20 to 40 FPS for cloud-based offline analysis when you need the best result. So now you have a question, how do you choose? How do we choose the model? So ask yourself, where will it run? That is the main point of choosing the model. Its edge, pick N or S. Cloud, pick M, L or X. And do you need speed or accuracy more? Speed, if you matter speed, then N or S. Accuracy, M, L or X. Then how critical are mistakes? Low stake, you can choose N or S. And high stake, that M, L, X is okay. So my advice is start prototyping with S. If it's too low, go to N. And if you need more accuracy, step up to N. Okay. So before that, this slide, I will just explain the transfer learning made. While we using the YOLO, you can run the predefined models in YOLO, because there are 80 everyday categories the YOLO already trained, the pre-trained COCO weights. The COCO stands for Common Objects in Context. That is in this slide. You can see person, traffic light, house, backpack, baseball gloves, and all. That's 18 day-to-life properties are there. And if you want to dictate any of this, you don't need to train a new data set. You don't need to create a new data set, and you don't need to train the data set. You can use the YOLO predefined weight, because the YOLO predefined weight is already able to detect these things, only these things. And apart from this, we need to create our data set, and we have to train the things. So I will explain what is transfer learning if you are not familiar with the term. It's like learning a new skill from someone who already knows the basics. Instead of that, in machine learning, instead of teaching a model from scratch, we start with one that's already seen millions of images. That's why we use the pre-trained COCO weights. This COCO stands for Common Object in Context. 80 everyday categories you see in the previous slide. The model you download has already spent weeks on powerful GPU learning these 80 classes, and all that training free for you. You don't need to train for getting this 80 classes prediction. You can just use the thing, and you just get a power feature extractor ready to go. And why this help? This help because fast convergence. The model already knows edges and shape, and less compute. You can fine tune on Google Colab for free, and generic features stay intact. Only the new classes need learning. So the process is 3 simple steps. Load pre-trained YOLO weights and prepare a small custom data set, maybe 500 to 1000 images, fine tune for few hours. For example, if you can take now after this some slides, we are going to do the real example. So my request is first request I already told to take a laptop, and second one, you just pick if you have laptop. I think most of the seeing this FDP using the phone. It's okay. If anyone have the laptop, then otherwise you can note that steps. It's very easy to learn, no problem. And after that, you can do you by own. Then you select a object not in this list, a specific object. Now you are going to select a specific object not in this list, because in this list you can easily use that YOLO already, that YOLO weight. So no need for custom object detection, custom data set training and data set creation. So please select one object not in the list. You can select, see all the objects, and apart from, and what is the, how you choose the object? So you see the car, you can select Innova, because if you put Innova for the prediction, the YOLO architecture gives it's a car. It will not give it's a Innova. So you can select the Innova and you can create a data set for Innova that I will tell how to make the data set. Like that, you can take that motorbike and also the bus, bird, anything you can take, but specific object, not in the list. Car is a very common that class object. So you need a specific object in that car class, Innova or Hyundai, that type of any car you can select, or any object in that list, not included in the list, you can select the variant of the object. Okay, I think you can select the things in while we are talking. And here, if you are using that custom object detection from scratch, you need 5,000 images and week of GPU times. But with transfer learning, you need only 500 to 1,000 images and 2-3 hours on Google Colab. It's done. So this is a game changer. Anyone with a laptop can build a custom detector now. We can do. I will tell how to do it. But here, we are not using that 500 to 1,000 images because we don't have enough time. So you just download 20 images, 20 total 24 images, and I will tell how to make the data set preparation. And after that, you can do if you want. I will show anyway. I will show the steps here. Then you can do with me. Then next slide is data set preparation. Before training, we train anything. We need data. Without data, we cannot train. We cannot model anything. This is the foundation. If your data is messy, your model will be messy. So first one is data collection. Here, aim for 100 to 1,000 images per class, and 300 to 500 is a good sweet spot. But make it diverse, different lighting, sunny, cloudy, or dusk, anything, that type of different lighting, and multiple angles, front, side, top, down, anything, that type of multiple angles, and real-world backgrounds, actual places where the detector will run. And it's also quality matters, no blur, good lighting, at least 642 into 640 resolution. And use your phone, shoot in the actual environment where you will deploy. And in step 2, annotation. Annotation means we are labeling the data. This object is this. We are telling the machine this object is bottle or car or these things. And we will use here, we will use makesense.ai. Make sense. There are a lot of platform for annotation, but here we will, for the simplicity, we are using the makesense.ai. It's free, runs on your browser, no installation needed. And draw the tight boxes around each box and export YOLO format. That's it. That's a data set preparation. I will show how it's happened. And the data set splitting and 70% of training. A model learns from this, and 20% of validation for tune hyperparameters and watch for overfitting, and 10% of test. That's final unbiased evaluation. And keep it random. No images should be in two sets. Or separate images we need. And actually, if you are making a data set, spend good time on data collection and annotation. A clean, varied data set beats a huge but sloppy one every time. So that's a very important thing. So I think I can move forward for that data set preparation thing. I already download 20 images and that thing. So make sense AI, we will go to make sense AI. or you need the time to download 20 images? What's your opinion? You need the time. You need time because if you are able to download 20 JPG images, that thing is you want to make sure your images is JPG in the format of JPG. Don't download the WebP images; it will not work. So if you have laptop with you, then you can download the 20 images and make the data set like this. Create a folder, data set, and there are two folders, images and labels. And in the images, you have two folder, train and var. We don't need test. Test is optional. And in labels, you also created two folders, train and var. Let me show you the data set type. Okay. This data, images and labels. And in images, train and var. And in train, 20 images. I choose the image for all different 20 images. And 70% that's var. In validation folder, 4. I accidentally put 5, so okay, 4, minimum 4 you need. So 24 images you need for this operation. 20 images in the train folder and 4 images in the var validation folder. So the majority of the audience doesn't have the laptop. Then we can go to the next slide. Otherwise, I have no problem, because if you want to learn from online, the real time, you can check, because some errors will happen. So if you are doing with me, I can correct. Otherwise, so you are downloading the images. Okay. Okay, then fine. I think you download the 20 images, and store it in the train folder. Then 4 images, the different images. That image means should be the same class. If you take a crow picture, there are different type of crow images you need to download, and 4 images in validation folder. So your final data set folder like this: images, labels, and train and val for both folders. But in images folder, in train folder, inside the images folder, there is a train folder. In that train folder, you have 20 images. But this 20 images only for our testing, because we don't have any time. That's why we are using the 20 images. You need to at least 500 images for the better training. But for less, just understanding the thing, you just download 20 images in the train folder, and 4 images, at least 4 images in the validation folder. Okay. Then you have to create a text file. I will show here that the right side. Text file is that you can name it data.yaml. That data.yaml, that format is train, wall, then NC names. And you just make that the YAML file. You can see in that slide. Okay, that I will do. I will tell how it's used, and you just keep the thing. Now, if you don't have laptop, you just imagine you have a laptop, and in that laptop, that there is a folder data set, and you are going to model a specific object. Not in that 18 class, you are going to train a specific object. That specific object's image in your data set. There are 2 folders in the data set: images and labels. And the images folder, there are another folder, train and var. And in train, folder, you have 20 different types of the same object, different images of the same object. And in the validation folder, there are 4 images, at least 4 images of the same object in different angles and all the things. And your labels folder is empty. Your labels folder, there is no train and there is no files in the train and wall images. And you also create the YAML file. You can name it any name. I call here data.yaml, but you can name in custom anything, model ML or anything, no problem. And in that YAML file looks like train or test. We don't need because we are not using the test. And NC, the number of classes that I will tell you, just leave it blank, and names also you leave it blank. Okay. Now we can move on to the next slide. I think at least you can imagine you have a laptop and all the data set. And the next thing is we need a platform for developing this data set and training the data set. That's our training environment ready. This is super easy and totally free. Open Google Colab. Google Colab, just you type the Google Colab and you will see a notebook interface, no download, no installation, everything runs in the cloud. And click runtime. I will show the working. And click runtime, change runtime type, select GPU. Just I will tell the thing. Now you are going to train the training in YOLO 11 tutorial. So for getting the YOLO 11 tutorial, you just type YOLO 11 GitHub. It's very easy to get the thing. Also you can get another ways. And here in GitHub, you can see the open in Colab. This tab, just click the open in Colab. And you can change your email ID. Here, okay, so already my one is open. Okay, now you get this type of framework, this type of platform. And here, first you connect in the right side, top of here, in the below the share button, this connect. Then you can see it's connecting. Then after connect, you just check the runtime. Runtime is change runtime type P for GPU. The Google generously gives the GPU for free for some hours. After that, you need to pay. So now we can use the totally free GPU. Then you check that GPU is here. Then save. Now before set up the YOLO, Ultralytics YOLO. Ultralytics is developed the YOLO. So you need to install the package of Ultralytics. So before that, you need to connect your Google Colab into your drive. So here you click. In that side, there is a files icon. You click the files icon. You can see the one folder icon. Then you just enter the play button. I think you all know, all faculties know how to use the Google Colab. Google Colab is nothing to use the Python. You can run any Python programs the Google Colab and easy for the machine learning and model development. I already don't know installation required, no downloading. And this box is called cell. You can type the Python programs here, and either you can click the play button or you can enter the shift enter, then that cell execute. And in Google Colab, every program is executed by cell. So now that Google Colab, our drive is ready, then Google Colab is connected and Google Colab is ready. Now we are going to install the Ultralytics setup. You don't need to do anything. You just play this cell, pip install Ultralytics. Then the Ultralytics will already that's downloaded. In the meanwhile, you need to upload your data set into your Google Drive, because if you are uploading here, that if the session is closed, that all the things will go. So you need to upload your data through to the Google Drive. you open the Google Drive and you can upload your data, that data folder into the Google Drive. And after that, you can see refresh. You can see your data is here. I show the data is here. The data. This is my data. This images is here, labels is here. But now you don't need to do the uploading the data, because you need to annotate the data and create the labels. So after that, you need to upload the data. Now I already uploaded because I already annotated the data. So I will tell how to annotate the data. If you are okay with the Google Colab settings, then I will move on to the annotation part. You are okay with the familiar, that easy to do with all the things with the Google Colab, then we can move on to the annotation part. It's okay. Google Colab is okay. Then after the annotation, you can able to upload the data into the drive. Then we will do the trade. If Google Colab setup is fine, then we will go to the make sense AI for annotating the data. Is anyone following with the laptop? Or if nobody is following with the laptop, then I can just show and I can move on to the next slide.
Sir, I think there are someone who is trying with laptop.
Okay, fine. No problem. I can wait. No problem. This someone is trying to happen is very interesting. So now the phase is, you are just open the Google Colab and you just connect your drive, and you just connect here the right side top below the share button. You just connect and check the runtime. Is it T4 GPU? Okay. Now all the steps done. It's fine. And after that, we are moving to make sense AI, and we are annotate the images, and we are downloading to the labels folder and extract the labels into the labels folder and uploading to the drive. Then we can see the images and labels in the drive. Okay. I think we will move on to the make sense AI. You just type. Okay.
Is there any hand raise? Is it for asking any question? Anjali ma'am. Okay, sorry sir. I think it is accidental.
Okay, fine. Then you just type make sense AI. And you can see the make sense AI. This is for the image annotation and labeling. And here you can see the get started button in the right bottom. You just click the right bottom and drop images. Here you can see the drop images, and click the drop images and go to the data set you already created. Here the data set and data, then images, then trade. You can select the all images at one time and make sure there is only JPG, JPEG and PNG images. Don't put in the WEVP files or any other files. And if you click all the files, you can see the 21 images loaded. Then, is anyone follow the same step? Then if this speed, my explanation is little bit speedy, you can ask to again to explain the things. You just click this button and you upload the images, 21 images loaded. Then click the object detection, because we are doing the object detection here. Then click the object detection. Then you need to label. Here I am using the all. Then just click, type the all, insert a label, and start project. Now you can see the 21 images in the left panel, and here the first image. And you carefully draw the rectangle over the object. First step. And the second step, you need to make ensure for the first images there is the label selected. Here the label selected in the third panel. So make ensure the first panel have the all images, and second, you need to draw the bounding box, and third, you need to select the label. And go to the next slide, next images, then you again draw the box, then automatically the images will come. Then again, next page, next images, then bounding box, draw the bounding box carefully inside the thing, then next. Next. Okay. And you have to draw for every images. 20 images, then you can draw the every. And this thing is make easier than other softwares. But for a beginner level, you have to do this by your own. Then after that, you can enhance your skill for annotation and labeling with another software. There are so many other softwares out there, but this one for beginner, for the 20 or 10 images, you can do, and you can feel that pain of the data annotators and labelists do the before this softwares came. Because we all know that ChatGPT and generative AI tools. Nowadays the students can write the programs with 1 second. Write a program. If you are giving that lab manual, this is your question, then they immediately type the question, write a program for this, and they get the result. So I think that, remember, there is a generation where there is no ChatGPT exit, and we search our program in the Google and sometimes in Stack Overflow and post the questions and ask for waiting for 3 or 4 weeks for the result and all that. So nowadays the students, that new Gen Z students, don't know about the Stack Overflow. They are not using the even the Google search tool. They are just generative AI. So that makes technology makes the things easy. But just now for the machine learning modeling, there are easy ways to do. But before that easy ways come, that data annotations engineers take so many times. They invest so many times and their hard work, their dedication for annotating a data for clean data set. So just experience that pain. That's for 20 images, we can do it faster. So I think if anyone follow the procedure, they already completed that time. Already that 20 images they annotated. And after annotating all images, make ensure all images is annotated. Then click the actions button. Then export annotation. You can click the export annotation. And here there are 3 formats: a zip package containing files in YOLO format, and VOC XML format, and single CSV. We are using the YOLO. We are now using the YOLO. So you just tick the YOLO, then export. Then you will get a zip file. In this step, most of them in first time, most of them make the mistake. Here you get the zip file. You don't get that actual file. You just get the zip file, and you just extract the zip file. First, you extract the zip file. Then, if you've done all the 20 images, you will see that 20 images. This is one I already will show. 20 images. You will show the all 20 images labels. Labels means this is the label file looks like. 0 is the class. There is only one class, so 0. Then the coordinates of where the object is located. Then you copy this 20 images file. Just copy the 20 images and go to your data files. Data already have the data files. Then here the labels file you paste into the train folders. Understood? You don't need to. The common mistake is after annotation, export annotation, you get the extract files. Some people copy the same extract file, that not extracted file, the zip files to the labels file. It will not work. You extract the files and you will get that 20 images, 20 labels. These 20 labels you copy into the labels train folder. Now you can see in the images files, there are there is two folders, train and wall. And in train folder, there are 20 images. And the corresponding labels files, also the train folder. And there is the same 20 labels files. Hope you understand the concept. If you have 20 images files in the images folder, the same labels files you have to create in the labels folder, labels train folder using the make sense AI. Make sense AI is for now you can use any tool for the for annotation. It's okay, but now is there is no time, no need for download the software. That's why I use the make sense. So the same process repeated for the validation folder. You can upload the validation folder, files into the make sense AI and annotate the images and export annotate, and after that you get a Excel file, a zip file, then extract the zip file, then copy the that four text files to this folder. Now your data creation is finished. You developed a data set. The data set look like this. I'll show. In your data set, all procedures will completed. Then your data set look like this. Data set, images, labels. Then images have two files, train and validation, and labels have two files, train and validation. Then uh, in all in train folder there are 20 images. The corresponding labels are in train folder, and validation folder there are 24 validation images and corresponding training that annotation labels files are here. So if anyone followed with my instruction, they can check, they can recheck. These are the correct format you built. If you are doing the same, you got the same format after annotating, you can upload your data set into your Google Drive. The same Google Drive associated with the Google Colab. You can upload the same data set. You can upload this data set folder to the Google Drive, but always remember the same email ID, the Gmail which is associated with the Google Colab. Okay. Okay, now I already explained the Google Colab setup. Then we are moving to the training configuration. I will show in the Google Colab how the training happens. Then you can feel the real experience. Okay, this is my Google setup. I already run this cell. You can see the pip install Ultralytics. Pip install Ultralytics means that they install all the YOLO features, YOLO packages in the using the Ultralytics. And first, now it's ready for that predefined weight. Now this is used for the predefined weight. And if anyone use the laptop, the same steps you follow, and if you are in the same stage, you can predict. You can predict means the YOLO predict model. You can run this cell, but here is a source. Source means the images you need to predict. So here they put the Siddhan JPG, and they already run the thing. Then they identify person, type. So this is the pre-built thing, and I changed that source to my image. But remember, my data set is not modeled yet. I only have the data set images. I am not trained yet. Then I check, and now I just use one images for as a source. You can open the train folder. Train folder, you can see the image. You can see here, you can see the image of a port. Then I copy the path of the image here. Here I copy the path, the three dots. If you click the three dots, you can copy the path. Then you can paste instead of this pre-built location, predefined location. Sorry, that thing here. Here you can copy the path, copy the path. Now what we are going to do is we are predict one image that already we have, not in the YOLO class we have, and let me see what will the YOLO give. What is the output of the YOLO? If anybody can answer, if I run this machine model, the predefined model, what is the answer? What is the answer YOLO will give? The question is, my question is, if I run this cell, you can see that for this images, they already run the cell. So the person and tie, you can see that detection. But here the image of all. So if I run these images, what will be the output? There is no person is available, but there are 80 classes. You remember that 80 classes? I show you that. I already showed this thing. YOLO can predict anything in this class. Anything in this class, if you give this anything inside this class parameters, the YOLO will predict. So what will be the answer of if I put this all images? Now I upload this image. Then what will be in the bounding box, what will be the label? Label YOLO give. If you can give the answer, that means you understand the basics of YOLO. Otherwise, I want to explain again. So that's why I ask. Anyone can try. Anyone can try, because happily failing is maybe bird. Bird. Okay. The answer is correct. The bird. Because in that 80 Coco text, there is a class is called bird. So YOLO can identify this image is a bird, but YOLO cannot understand this is a owl, because there is no training for this owl. We are doing the corresponding training for the owl. Now you understand the concept. I think you understand the concept. If anyone have doubt why this is bird, then I can explain. Otherwise, I can run this slide, run this cell. Okay. Hope you understand why YOLO provide the prediction as bird. Okay. Then I run the cell. And within seconds, that output is here. Content, runs, detect, predict. So you open here. You open the second. Open the runs folder, left side, runs folder, detect, predict, then open the thing. And then you can see the answer is bird. Fine. You understand? So the YOLO will provide the basic classes. The slide the 80 classes. Anything you can provide, the YOLO will give the prediction that most relating thing. Most relating thing means if you put a crow, then it will say bird. That's the type of, if you put a car instead of its SUV, like Innova or Krista or anything, they only mention the result in the result. They only mention it's a car. So if you want a specific object, specific object detection, the custom object detection is matter. Okay. Hope you understand that prediction method of YOLO using the pre-trained weights. Here we are using the pre-trained weight. Pre-trained weight means YOLO 11N. So they provide only the there within the class limit. And now we are going to train our model. And we will get our best PT, PyTorch model. Then instead of YOLO 11 NPT, we will put our own model. That I will explain what we are going to see after. That's why I explain here. next step, next few minutes, within few minutes, we will train our own model. Then we will get that YOLO, instead of YOLO 11 and PT, we will get a best PT model. Then we replace the best PT model here. Then we run this cell again. Then the YOLO will produce, instead of word, the YOLO will provide the result all. That specific label we give in the time of annotation. Hope you understand the custom object model method. Okay. So before that, let me tell you some technical points for the YOLO. So this is the YOLO class. You can use, if you want to detect any object, any exact objects in this class, you don't need to train any data set. You need to use the same YOLO weight, no problem. But if you want to a specific object, then you have to create a data set. So before start your work, you must ensure your model needed a data set or new or the next that already defined one. So making the data set is a lot of time. So we can skip that. So we already discussed the data set preparation workflow and data set architecture and configuration and Google Colab setup. Then the training configuration. Training configuration means the configuration patterns. The data equal to data YAML file. I already told you to create a data YAML file, and I will tell how to use that YAML file. And here the base model. Base model is YOLO 11 NPT. Then while training, while the time of training, we see the epoch. Epoch means iterative looking. Iterative looking means if you are give the epoch is 15 times each images is visited. Each image visit and the system understand this one is this car, this one is this car each time. So if you have 20 images, if you put the epoch 50, then each images will iterated by 50 times. So 15 into 20 times this system will. So if you are small data set, you can increase the images. Then image size, you can reduce the image size or increase the image size depending upon the product. And batch size 60, 32, 64. You can create your batch size according to the what I said, according to the your model size. The batch size will determine the model size. If you are large data set, you can decrease the model size, because while you are running in the program, it's not that much problem in Google Colab. But if you are running in the program in Python, then it will become the batch size is too large, so you can reduce. And early stopping. If your object is too much good, that detection is too much good, and you don't need to check all the images while running the training process, you can identify. Then that type of stopping, you can early stopping, you can add. That is a patient citizen. But for the normal thing, we don't need the patients. We just use the epoch and images. So evaluating model performance. Before evaluating model performance, I just teach how to train a custom model. Okay. Then after that, we will evaluate the model. Okay. So we will go to the Google Colab slide again. I think at least one participant have the laptop with all the steps completed. At least one. No problem, because we all attend the FDP with the mobile. So for our convenience, we don't take our laptop, and we don't expect the practical in the online FDPs for 1 hour or 1.5 hour FDPs. We don't expect. Actually, I will not expect if I am participating in online FTP that the resource person will tell to take the laptop and do the things. So I also use the mobile. So no problem. But if anyone have the laptop, anyone follow the same step, then they can see what happens in their laptop. Okay. Otherwise, you can imagine, because we have a lot of creativity in our mind. So you can imagine, I have a laptop and I have all the data set in the Google Colab, and I annotate all the data and uploaded the data. My data set is in the format. This is the only thing you have to remember. My data set in the format data, images, labels, and images file. There is train and val folder, and labels file. There is also train and validation folder, same as the corresponding images. Because if you are annotate the correct way, if you have 100 images or 20 images, 50 images, you annotate the 50 images without missing one. The number of uh, labels train folder and the images train folder must be same. If this is not same, the problem will happen. If not same, in the time of this training, it will not match. So it's 20 images, okay. We can read again, we can annotate the thing and we can label thing. But if you are taking 100 or 1,000 images, then after annotating all the images, then you are the time of the training process, you are realizing there is one image is missing. That's very painful. That's very frustrating thing. So before start training, make ensure all the number of images and number of the labels is same. Okay, then we will go to the training part. And you remember, I told you to create the data.yml file. Then you just upload the data.yml file here only. No need to, if you upload the data drive, no problem. It's okay. But if you want to, we don't want to upload into the drive, just upload here. Here is the upload button. Then you can see that data file here. Then open. This is the warning because ensure that your files are saved elsewhere. This runtime files will be deleted when this runtime is terminated. That's why I told you to upload the drive. Drive is every time it's there. But for the testing purpose, no problem, data.yml. And you open the data.yml file, you can see train var nc1. I only use one class, then nc1, then you can see the all. And this is a Unicode expression, so you just follow the same pattern. After nc colon, you just give a space. Here also, you just give a space. Then here, train. Train, you just make a space, and in the left panel, you go to the data folder which you uploaded, then images, then train. You can copy the path here, copy, then paste here. Okay. Then second, the same thing, you have to copy the var. So you just change the name here. So now your data.yml file look like this. Train, the location, validate folder location, and number of classes is 1, and names is all. Okay. Then we are going to down. Here you can see the train, YOLO train model. Then you can see YOLO train model is equal to YOLO 11 and PT, data equal to coco.8 YAML, epoch 3, image size 640. By understanding all these things, anybody can say how to change this instruction according to our custom model. Anybody can say in what changes requires for training our model in this model, in this line. There is some small changes needed. Epoch we have to change. We must change because only we have 20 images. So epoch needed 50, at least 50 for the some getting the some result. But there is one more change needed. Only one change needed. You can look at the instruction, and we are using the transfer learning. Transfer learning. I already discussed the transfer learning here in the slide. The transfer learning means we already learned the skills from already the understand person. So YOLO 11 and PT is there. We must use the YOLO 11 PT disk. Then where will be the change? You can try, at least you can try the answer. Data, file name, and size. Yeah, exactly. You can change the Coco 8 YAML because the Coco 8 YAML is used for the pre-trained YOLO 8. This is already there. 80 classes are there. Now we want to use that our own data file, our own data set. That's why we created the data.yml here. We already upload the data.yml and we change the train and here we change the train and wall folder path. So you just copy the path. You just copy the path and paste here. A small one more change because our data set have only 20 images, so we can use instead of n is m. Then epoch is 3, so also 3 is too small, so we use the 50. Now it's okay. It's ready to train. What is going to do is for data content data.yml. You can see this line. In every iteration, every epoch, they go to the images file and the labels file, corresponding label file, and the system understand this image is old. This image is old because of the texture, because of the texture of the bird and the edges, shape, and the system understand. System is memorizing the things. We in the childhood we memorize all the things. This is this. This is this. That type of learning happens. That is called actually machine learning. That type of learning happens here. That system understand this is this. This is and how that number of times increases. The member that system performance is increases. That's why we put 50 epoch. So after that, now this is the challenging part. If everything works, everything is do the same you follow the same pattern. If you are running this cell, it will work fine. But any step you made mistake, it will produce error. So I think at least one person among 182 participants, at least one person will follow the all steps. So he or she can check whether the steps are correct or not. Maybe I think maybe I before seeing the thing, I just run all the things to make sure it's all working. That's why I am very much confident this will not get error. But in your case, you are doing in the first time. First time is okay. Everyone is failed. We are not ready to walk in the very fast in the age of 1. We are getting falling and and wake up and all the things we learned. So no problem. You just run the cell. Then if everything is fine, there will be error. Okay. Here the error is okay. This model is YOLO 11M and data is content data.yml. If anybody gets this type of error, then that's the problem is the location, that you are not taking that correct data YAML location. I just copy the thing, and before showing the thing, I just run all the things and I got the best.pt and all the things. But if you are getting any error, you just ensure that the thing is fine from the start to end. And here we can check data equal to content. Major sequence for then is anybody doing the same thing, training with all this data.yml? Okay. Then your training is started. You can, if you are doing the same thing, you can see this will happen. The training is started. That before it happened is I just copy the train to the wall on the right side. So it's a Unicode. So sometimes you don't need to do that thing. You can just copy from left side and copy the path. Then only it will work. But it depends. Sometimes it's work and sometimes it's not work. Then you can see the GPU, that epoch 1, 2, 3, 4, 5, 6. And don't worry, it's take only 2 or 3 minutes maximum. But if your data set is too long, it will take 2 or 3, 4, 5 hours. And I hope that one person who do the same thing, he can get the same steps here. And I want to make you understand that making a single shot algorithm is very simple. But there are some other things we have to discuss after that. So in your imagination, you have to make ensure the data set here. In data set, there are two folders, images and labels. And images, there is train and var. And validation, there is also train and var. And in the image folder, the corresponding labels must ensure the labels folder that you are using make sense AI. And after all that makes sense and all this work fine, you uploaded the data set into Google Drive. Then you create a data.yml. Here in data.yml, you copy the path of train and var, and also the number of classes one here, number of classes one, and names. Names is your data set. Okay, the training is completed. And we will get the, no, you get the PyTorch model, the trained model here, content runs detect train. So we can check here, that's it, runs detect train. You can see the weight folder. You can see the weight folder. Then weight best.pt and last.pt. So you can select the path best.pt, copy path. Then you have to move to the folder. Now you have the trained your data set. Now you created your data set. The data set is best.pt. Now you want to check your data set is working fine. That's the thing you have to check. So here, instead of YOLO n11.n.pt, you copy your data set best.pt. Hope you understand what I am doing. Now you are using the transfer learning. You created your own data set. In your own data set, you can identify the all exactly. You don't need that data set will not provide. It's a bird. It's a all. You can create any type of object. Instead of all, you can use any type of object, this type of data set creation and data set modeling. And you are going to check that this, how your data set, your newly data sets work. You can open the images file, then validation folder. You can any image you can copy. Then instead of the source, the previous file, you just include your file. Okay. Then you run. Using your own data set, you are going to run. Then the result is predict2. Result is in predict2. Then you're going to open the predict folder. Runs predict 2. In the predict 2, just you can see your data set performing well. 90% is confident. The data set provides the exact label all. And you can see the left side, there is another all 0.49 confidence because there we don't have any much data, only 20% data, 20 images of data. So they think that there is a all, that's why it's 400. But that less than 50 confidence, we are not considering this object. So you created your, if you are follow the same steps, you created your own data set, and using the custom object detection, you detect your own objects. Hope you understand what is custom object. And if you have any doubt, and if anyone follow the same step and feel any error in the middle of the process, you can ask. And if there is any other error, if anyone is not following, it's okay, no problem. But you have in mind and you can try it later. If you have any doubt, you can ask. Otherwise, we will move on to the next phase. Okay, I think either you got the output correctly or you are not following. This is not a problem, not at all a problem. So you can try. I told you can try later. Then I will explain the next slide. That's sorry. Okay, now I hope you understand what is object detection, the difference between image recognition and object detection, image classification and object detection, and the importance of YOLO and importance of this transfer learning. And the architecture of YOLO works. It works like a sliding that grid type modeling, and how to create a data set. In the data set, the most important part, the data set folder's name is images and labels. That is YOLO standard. You cannot name image and label. You can only use the images and label. And the image folder, train and val, and that labels folder, also the train and val. And the next thing is you have to make ensure the make sense the labeling and annotation part. In the labeling and annotation part, you don't miss any images. You have to check before uploading to the drive. You have to check the correct images and labels files are same. Otherwise, in the training time, it will make the error. And after that, you make the data.yml. For the data.yml, you have to exactly copy the path of the training folder and the validating folder and make the number of classes same, and the same exact label name you have to put in the data.yml. These all things happen, then you can directly go to the training part, change the epoch according to the number of images, then you can get a clean, good data model. Okay, and after that, we are going to evaluating the model performance. Now things all are dense. That actually there are some points in the machine learning and modeling you have to remember: precision and recall. Precision and recall, and mean average precision, and the training output, best practices. I already discussed the best.pt is our best model. And some terms I will introduce some terms. True positive. True positive means detected objects that really exist. That is good. Fine. Then false positive. False positive means detected object that are not there. That is false alarms. And in our testing time, you see two alls. One all is the detected object. That is a true positive. And there is another all, but that is not there. That is a false positive. And next one is false negative. False negative means that real object the model missed. That is very dangerous. If you detect the object that or not in there is not that not much problem, but the real object that model means is very dangerous. So precision equal to the true positive divided by true positive plus false positive. That is all detection the model made, how many were correct. So high precision equal to few false alarms. That is the major thing in the precision time. And recall. Recall is the true positive divided by true positive plus false negative for all real objects. Yes, how many did the model find? And high recall is few misses. So there is always a trade-off, tighten the threshold. Precision up, recall down, and loosen it, it's opposite. So next is the mean average precision. Mean average precision is a gold standard. And mean average precision is at the rate of 50. An average precision when a box is correct, if it overlaps ground truth by 50% or more. Because we need a 50 to 95 mean average precision. That is the good thing. So you can see the, if you are running, you can see the confusion metrics and result.png, how the you are training well done. So I'm not going to do that too much details because our time is not permitted. So now you know how the model is trained and you know how to get the best model for your requirement. Then we already did the training and testing custom model inference result. You can see the output here. We use the best.pt for optimal performance and a flexible input. The process images, you can give any images according to your object, then that will detect the correct images. Okay. Next, the model export for deployment. Now we are that time ending, but we are going to the major important part of this machine learning, so-called AI and machine learning modeling and all that things. That is, this is the deployment slide. Deployment slide means it's a practical thing. Okay, you have trained the model and you have trained the model and tested. And now let's get that model into the real world. What do you have? You have the best.pt. Best.pt means a PyTorch checkpoint. It's a PyTorch model with all trained weights. You have all the trained weights, but it's not, you cannot deploy the PyTorch directly into the real world because PyTorch is heavy. It won't run efficiently on phones and the hardware boards or embedded device. So we need to export the model. We need to export the model to ONXS. ONXS is cross-platform servers, and TensorRT is Jetson Nano, that NVIDIA Edge model. For TensorFlow Lite, that Raspberry Pi and Android ID. Then Core ML for iOS and Mac OS. Because without that optimization, you cannot export the model for for the deployment. So you think that model export deployment is very difficult. It's not very difficult because the YOLO provides the easy way. I will show you the easy way here. In the Google Colab page of the YOLO, you just down. Then after the training, you get the best.pt. Then export model. Simply you select your format here. Then you can upload your best.pt here. Upload means you can copy the path here. Then I will show what type of export you can done here. TORCH script, ONXS, OpenWindow, Engine, Core ML, Saved Model, PB, TensorFlow Lite, and this type of models you can directly export. Thus, your best.pt is directly exported into that model using YOLO. That is the power of the YOLO that which provide to the common user. So now the last slide, the future of object detection. In this slide, I want to talk you some little more theoretical part because we are all done on the practical side. Before we wrap up, I just want to glimpse of where this field is heading. First one is vision transform. Instead of looking at images piece by piece, this vision transformer look at the whole picture at once, and they understand context better. And models like Syn Transform and YOLO Whales are using this. And next one is learning from few or unlabeled images, a few short self-supervised learning. A few short learning means learn a new category from just 3-4 images. And self-supervised learning is learn from millions of raw images without labels. Without labels is very risky, but this type of that research experiment is doing. And this saves tons of time and money. And next one is 3D object detection. Using LiDAR and depth sensors instead of just cameras, the model knows exactly how far objects are, and essential for autonomous vehicles and robotics. You know that our world will definitely move on to the autonomous drivers, either we accept or not. And multimodal detection, and you can tell the model what to find using text instead of all that programming and all the complex things. Just type find the red backpack. Then models like clip and clip can dictate objects they have never been trained on. And last one is edge AI. That is not last one, that is the first one. That next few years you will experience all the power of edge AI. A running detection on phones and hardware device, Jetson Nano, Raspberry Pi wearables is faster, more private and cheaper. So object detection is moving towards model that are, you see, the smarter, lighter, more flexible, using text, 3D and self-learning, running on small devices, working with fewer training images. Better accuracy, less data, and faster performance, ready for real-world use. So this is the contents I want to deliver to you. And before closing the session, I think all the most of the majority of the audience are from faculty department, so the faculty side, and some of the researchers are there. So, being a faculty, it's very difficult to understand the out of the box content because I already have the faculty experience 7 years. I was a faculty, so we have currently we have all so much paperwork and all the things. So, being our own research, doing our own research, it's not difficult to get all the new ideas and technologies. So, but the what opportunities there is, you can get your project. We have to get your project students in BTech or MTech project students, and we can tell them a correct path to explore the new ideas because they are ready to that. Also, the Gen Z students are ready to explore the new that adventurous way. So. What we are going to do that I will tell. But before that, I just again I recap what we have learned: single shot architecture, that one pass, fast, accurate, and training and evaluation from data preparation to the model and model export, converting to ONNs and TensorRT and anything we want. And the most important part is hardware deployment. Hardware deployment is the most important part in the AI development. Just think what happens to most AI projects after they are built. If you have any experience, there are most experienced teachers are there. They already built some fascinating and beautiful AI models. And what happens to most AI projects after they are built? That is my question. If you are not able to do the models yet, you will going to do that things coming days, coming years. You will definitely going to do. Now, here the answer is the surprising answer. 90% of AI projects never make it to production. 90% of AI projects never make it to production. You just think about that. 9 out of 10 AI projects fail. 9 out of 10 AI projects fail not because of the AI doesn't work, but because of the engineer don't know how to deploy it on real hardware, real device. That's the point. Why does hardware matter? Because AI that stay on your laptop is fine. You can say I build a model. It's very good. It's very accurate and it's very fast. The model stays on your laptop. It's just like useless because if you are not deploying it to hardware, it's like a property is sitting in the museum. You can see and you can enjoy, but you cannot touch. Real AI runs on actual devices. Your phone, security cameras, robots, and factory machines, medical device. So many. Most the problem is I found in nowadays that AI courses and all the things. Actually, in the syllabus, KTU or any syllabus, the AI teach you to build models. And we are satisfied with that building models, and I can build any models with any type of models, two part, two stage, one stage, any type of models, because we teach you to build that models, how to build models. But as a faculty, you have to guide your students to teach, to either you teach or they tell them to study, to know how to build the model and deploy. That small way deploy, that's what separate the pupil, that students who get hired from pupils who keep applying that AI model, AI field. Because the AI field is fascinating. We are thinking the AI, if you are studying the AI, we will get, the companies will queue for getting that hired. It's not happen because everybody can build the model. Everybody can train the model. So you build an amazing AI model, it recognizes face, it detects object, it works perfectly on your laptop. You are proud of it and you have worked hard on it. But you are a student. If you are not changing the career to that company, it's okay. But if you're a student, if you are a project student, do all the things, then that company says, great, now put onto a small device. There is the problem because your laptop has 8 GB of memory and this device has only 2 GB. And your laptop takes 2 seconds to process an image, but this device needs to do it in 100 milliseconds. That's 20 times faster. And your laptop is plugged into the wall. This device runs on a small battery. And what happens? Your model crashes. It's too big, too slow, and doesn't fit. This is why AI project fails. They work in the lab, but die in the real world. There are techniques to solve this problem that you can tell your students to. That's why you are not stopping your AI, all this research in this model building. You have to move forward on the next step. Conversation, TensorRT, and smart architecture design. There are a lot of ways. And when your students learn these skills, something interesting happens to their career. These companies will pay they more, 30 to 50% more than your typical graduate. Why? Because they can actually make a work in the real world. And I see some of interviews in IIT that we said we interview for researchers for the research projects for the graduates. Most graduates back into interviews and say, I can build models. But if you can deploy, these students can work and say, I can build model and deploy them on real device. That is a completely different conversation. All of them need AI, no doubt. But there is a critical point. They need AI on device, not in the cloud. Why? You are thinking about the question. This self-driving cars can't wait for cloud response. When a child runs in front of the car, you need decision in millisecond. Cloud is too slow. And factories often don't have reliable internet. Machines on the factory floor need to run AI locally. Then hospital cannot send patient data to external servers. This privacy regulation require on device processing. And for everything, cloud computing is expensive. Running AI on billions of devices through cloud would cost trillions. And the solution, a solution is edge AI. AI that runs on the device itself. The current scenario is most AI graduates only know cloud deployment. They can use, I already teach you that Google Colab, and you can run AWS servers, any server, Google servers, any server, but they cannot deploy on actual hardware. The result is the companies are losing millions of dollars. The project fails, timeline slips, and product doesn't slip. Without hardware skill, here is your student situation. The students are one of thousands of AI graduates. They're not theory, but not deployment. They are competing with countless similar candidates. And when technology changes, they are vulnerable. But with hardware skill, everything changes. They are rare and valuable. They turn algorithms to real products. And they are positioned for the future because AI is moving from cloud to edge. This is not a prediction. It's already happening. You can see in the real world, you can see. I already tell your phone runs AI locally. Your new cars process AI on board, and factory robots have built-in AI chips. And medical devices are getting smarter, and home applicants are becoming intelligent. Billions of devices will run in the next decade, billions of devices. And companies need engineers who can deploy AI on these devices. But most AI education is still stuck in the cloud only way. So AI is leaving the cloud. It's landing on every device around us. The hardware fluency makes you a builder of real products. It secure your student's career for the long time. You to the awareness is this is just about getting their first job. It's about building a career that lasts 20 or 30 years. That I repeat, the most programs teach you to build AI. So tell your students in the project how to build and deploy AI on real world. Again, I repeat that one word, deploy. That's the difference between being another applicant and being the candidates companies want to hire. That's your advantage. That's your student's future. Okay. Thank you so much for your time and attention. If you have any questions, I'm happy to answer them. Okay. Thank you.
Sir, there is a query in the chat box like, will you be sharing the tutorial collab notebook for the reference?
Yes, of course, because that tutorial collab is not made by me because it's already available in the net. You just type the Google YOLO Google collab, then you can see the that Google collab. Sorry. Also, I will share the link to the coordinate.
Sir, there is a question like, how important is large scale pre-training for VIT performance and detection task? Sir, am I audible?
Okay. Yes. What is the question?
So the question is like, how important is large scale pre-training for VIT performance and detection task?
Uh, Actually, the question is large state pre-trained. I didn't understand what he means for the pre-trained way.
Sir, like
Ah,
pre-training for VIT performance and detection task.
okay. In the we don't need that much pain, that much time, and all the things for VAT training. The vision transformers. Vision transformer is another level of detection. So the pre-training concept is for the single shot object and object detection and two-stage object detection. Here there is another type because that in one scan the vision transformer know the understand the concept, understand the context. So if we are using the vision transformer thing, we don't need to spend too much time for that training and all the things. We can use the that excellent features of PAT, and you can use that in your project. But the important thing is whether that our project requires the VAT, that vision transformer is really needed, is really matter. Then only we need to move on the vision transformers. Otherwise, if we need to, if we need a small task, don't need to, we don't need a JCB for that putting a tree or planting a tree. So we just need some handheld devices. That type of thing, if you are using the vision transformer for your small task. So that is important. The question is how important. There is vision transformer level is if your project or your research problem is too much complicated and you cannot afford with YOLO and or other training models, then you can use the vision transformer.
Sir, there is another question like, can you once more tell what is the difference between precision and recall in object detection?
Okay, okay. I will tell. If you want to see the slide, I will share. Otherwise, I will just 1 second. Okay. Here, this precision and recall, the core metrics. First, you understand the terms true positive, false positive, and false negative. These three things. True positive is detected objects that really exist. Detected object that really exist. If you remember, I run the that inference on that our custom object model. You can see the all that bounding box with all 0.96 confident. And false positive. False positive is detected objects that are not there. That is a false alarm. The detected object that not there is also one box all, but there is no there. Then false negative. False negative is F1. Real objects the model missed. Real object model means if you are running a model, then the inference doesn't get that model that object. Then it's a false negative. So precision is of all detection the model made. How many were correct? That is the precision of all detection the model made. How many were correct? And recall of all real objects. How many did the model find? That is the difference between precision and that recall. Precision of all detections the model made. How many were correct? The high precision equal to few false alarm. Then recall means of all real objects, of a real object, how many did the model find? Then high recall equal to few misses. That you can see precision equal to TP by TP plus FP, and recall is TP by TP plus FN. That is the difference between precision and recall.
Thank you, Sri. I have one more question. Like, how does YOLO handles multiple detection for the same object? Like, is there any relation with the confidence score?
Multiple object means can you multiple
The
multiple
multiple
detection?
detection for same object.
There is no multiple detection of same object. There means if in the image there are same type of objects in two or more objects in the same object in the image. That's a thing I think that participant is asking. I will show the slide. The initial slide. Here, handling multiple objects or the same object. For example, if another question is there, I will answer first. I will answer to this question. Multiple detection of same object. You don't need to anything because if there are cars, you need to identify the car. You just follow the same pattern, and the YOLO will detect each car one by one. That is the YOLO's algorithm power. Because for each object, there is one center point. So the center point, they identify that this one is car. Then next object is this one is another car. So if you want to detect 100 cars, then you just follow the same pattern. The YOLO will automatically detect initially YOLO will consider this is an individual object. Then after the bounding box and the confidence making, they understand this is a car. So no problem that 100 or 1000 objects are there, same objects are there, YOLO will easily find the answer. Easily bounding box they draw and you can see the underdog box. The second question, I hope that is the question that asked. Second question, I saw one more question. If a single shot algorithm detects many false positive, what changes can we make to improve accuracy? If a single shot algorithm detects too many false positive, that means that your data set is not sufficient. Data set is not give you the exact texture and shape and edges to the algorithm to detect whether the object is there or not. So you have to give more correct, accurate. Otherwise, your annotation is missing. So either before you change the data set, you can you can increase the epoch and also the image size. Image size 640 is to change to 320 or less change. Then, if there is no changes in the accuracy, then you have to revisit the data set. Then you have to revisit. Then you will see that algorithm, either the data images problem or the annotation problem. You cannot see a lazy annotation. Lazy annotation will leads to the entire model will uh, flop. So you need a you pay attention to that annotation stage, and you need to make a correct annotation, because overlapping to another object is also makes a problem. So first you before my advice is, first you make a data set. You just begin with 20 images. 20 images, 70% of 24 images validation, and 20 images this train folder, and you follow the same step, data.yml and all things. And after that, then you check the confidence score. And confidence score, you will get 96%. Then okay. Then you follow the same images pattern. Same images, not same the redundant images. That good the resolution, high resolution images. Then make the correct annotation. Then the data model will not go. Okay, next question. I hope I get the how do we how do we balance accuracy and latency when deploying models on edge device? That is an interesting question. How do we balance accuracy? Before deploying the model into edge device, you have to make sure what you want, accuracy or speed. That's the important question. If you want accuracy, you need you need to sacrifice the speed. If you want speed, you need to sacrifice the accuracy. Here, the YOLO and some NVIDIA provides the Jetson inference. NVIDIA Jetson inference. These two models works. We don't need to sacrifice the accuracy and latency, because if that accuracy means that's because that depend upon the that objective. Because if that the device is very much cost effective, definitely either accuracy or latency will suffer. But if that object, the hardware object, you can deploy your model in 3,000 rupees hardware. The same model you can deploy into a 16K 16,000 hardware. The same model you can deploy into a 50K hardware. The same model you can deploy into a 3K or 3 lakh or 5 lakh hardware devices. So it's depend upon the objective. If the company needs the precise accuracy and the speed, they need to pay more in the hardware. The model is same. Model is not doing anything much. You can optimize, and condensation is done. You can make the model lightweight. Okay, that's all fine. But if they need the cost effective, if a critical action, for example, the rocket launching, you need to complete in 10 seconds. That time we don't need to we don't have to say we cannot spend 1 lakh for a machine, because for rocket launching we did crores, thousands of crores we need to spend. So that time we don't want to say, oh, no, I will only pay 1 lakh 10,000 for a hardware. It's not working. So depending upon the objective, the hardware price is increasing. So, but most of these items are not time critical. Time critical is only that car, then medical device, and this aerospace operation. Other things are 1 or 2 seconds are okay. That time we have to optimize we have to remove the weights of the models and make it lightweight. There are TensorFlow models. You can export the YOLO model to TensorFlow, and we can use the thing. Okay. I hope.
Sir, one more query regarding the deployment strategies. Like, how will we choose the deployment strategies, and what will be the best? Like, I
Okay.
have heard of A/B testing kind of things.
Deployment strategy that I already discussed in the previous question. That is the
So it is connected to previous question only. I understood.
yeah, that
Regarding what you need, like.
only thing is, I already told that deployment. Without deployment, your model is useless. Your model is nothing to do for the society or anyone. In the laptop, you can see in every morning you can run and you can see the result and you can proud of it. That's the only thing. But while moving on to the deployment, real deployment, the most important part is the cost effective because we are thinking about the product oriented model. So if your model is a social impact model or anything, any model, the customer consumer model, any model, social impact model, this will make use of for the common people. So the India is a middle class consumer country. So we are focusing on all devices for the middle class. So the price should be affordable for the middle class. So the deployment strategy is first you have to deploy your model on Raspberry Pi. That is the first thing you have to do. If you are a machine learning model, then you want to make it a hardware. But the problem is if you make a machine learning model that time, starting time onwards, you have to think, I will going to deploy this. Otherwise, there is no use of it. Either nobody want to buy, okay, no problem. But your goal, ultimate goal, is to deploy this model into hardware and just see the this working real, not in laptop. In laptop, any model can work, no problem. So first, you have to use the Raspberry Pi. If the Raspberry Pi is satisfying your speed and accuracy, no problem. No need to switch on to Jetson Nano. Nowadays, everyone is want to do. There are a lot of papers in embedded system. Lot of papers are doing Jetson Nano. So implementing this model in Jetson Nano, that is a new innovation. They said that is a new innovation. But the question remains: if you cannot optimize your this hardware, this model for the hardware optimization, that's why you are doing this in Jetson Nano because the same model you can use in Raspberry Pi. Pi is cost only 5,000 rupees. Jetson Nano is cost 50,000 rupees. So the deployment strategy first we start from the lowest model because hardware optimization in your research work, the word hardware optimization really matter. I made my model to optimize for a hardware that only have the 2 GB memory and this limited battery, this power. That I can model, I can deploy this model. That's the main important thing in your research work. So otherwise, you can say I deployed my hardware model in hardware that cost 5 lakh. There is no point. You can use the model in your laptop and you can see. That's the deployment strategy. Choose the least one, and then it's not working, then you can.
Thank you, sir. Got it. Any other questions from the participants? Any other questions? If not, I think. So I think we can wind up the session because there is no more question from the participant. So I request the coordinator to share the thank you note to our resource person.
For the entire participants of this session and from the side of coordinators, I would like to extend our heartfelt gratitude to Mr. Lomin Joy for this insightful session today. We are grateful for your session that you took the session from the very basics, your session to develop a system from the dataset preparation was really helpful and informative. Integrating theory as well as practical session, teaching us to how to use Google Colab effectively is really appreciable. Introducing us to how to develop a single shot algorithm from the very basic will really help us to develop our own project and encourage us to dive deeply into it. We are trying to keep up with you, sir, even though majority of us don't have a system with us. And thank you for your patience, sir. And thank you for this wonderful session, sir. For the entire organizing committee and all the participants present here today, We would like to present our token of appreciation in the form of a virtual memento. Thank you, sir.
Thank you. Thank you very much.
Sir, so happy to see so many feedbacks like excellent session. So we are so happy to see that too. Thank you, sir, once again. So dear participants, in between, let me guide you through some of the aspects in your AICTE portal, which may be helpful for you to finally complete the certification process. So you can see on logging into your AICTE portal, you can see this is the set of menus available for you. Out of that, one thing which is important for you to attend at the end of the thing is assessment menu. So at the on clicking on the assessment menu, you can move to the assessment which is available only after the completion of the FDP. Then once you complete the assessment, you can see the test mark over the this particular menu, and 70% score in the assessment is mandatory for getting certified for the FDP session. And next, on completing the assessment, you have to complete the feedback. So feedback will be available only on the last day of the FDP, and assessment also will be available only for one day after the completion of the FDP. So we mandatorily require all the participants to complete the assessment in this session itself on the last day. And then finally, on completing assessment and submitting feedback, attendance starting from tomorrow will be calibrating the attendance and will be entering the attendance in the portal. So after calibrating the attendance, you can view the attendance in the portal. Only with 80% attendance, you will be eligible for certificates. And finally, this is the last menu where you can click and download your certificate from. And moving on to some more details. So assessment, you can go to the assessment. You can see on clicking the assessment tab, you can see all the assessment. If you have registered from some other workshop also, you can see the assessments here. So this is the assessment. You can see the date and also the application number. So 8/12 to 13/12, that is our FDP. On clicking this particular link, there is a test link over here. Currently, it is not active. So on clicking the test link, you can move on to the questions. A window like this will be appearing in the screen, and you can just click on I have read, understood, and will adhere to guidelines. I will also share on AICTE portal guideline. Then you can click start and you can take the test. So test will be displayed as one question per screen. You can answer the question and move on to next. And finally, you can submit the assignment. And feedback will be menu will be looking like this, and you can click and complete the feedback of the session. So with that, one thing we will regret to inform you that is next session plan for today was of Ms. Abhijit. Abhijit had agreed to take 2 sessions, one on LLM basics and then applications with LLM. So we are very we regret to inform you that today's next session stands cancelled. Because the resource person who is currently at an overseas job location, we all know that AICTE FTPs are approved almost 6 months back. So he's currently on his overseas job location, which is having some certain secure site restrictions. So he tried his level best to join the session today, but due to his ongoing work assignments, he could not be out of that, and he has informed us it is impossible for him to connect today, but he has certainly assured us that he will handle the session tomorrow as promised, and we will be sharing the updated schedule shortly. And we hope that you you will understand the situation and cooperate with us. So we will be winding up today's session with this, and we will be starting at 6 p.m. itself tomorrow for the next sessions. Tomorrow's session will be handled by Professor Chandan Karfa from IIT Guwahati, and then Abhijit S. Pillai, who is a software engineer at 60 Technologies, and on LLMs. So with that, we will be winding up sessions. If you have any other queries, you can ask. Feedback link is shared. I'll be sharing that in WhatsApp group also. And dear participants, we also have to take a group image with videos on. So tomorrow, day after tomorrow, we have to conduct that group photo session. So kindly be prepared to switch on your video and be available. Okay. So thank you everyone for being with us. See you tomorrow.